This is a rectangle. To find the area of this rectangle, I multiply its width by its height. A rectangle is one of the most common shapes we see in maths at school, so it's fortunate that the formula for its area is so straightforward. This is a parallelogram. This is a little bit less straightforward. However, the area is still its width multiplied by its height. I think it's interesting that I find the area of these two shapes in the same way, and in this video I'm going to explain why this happens. This is Mr. Butler Maths, and in this video we are looking at all things parallelogram. I'm going to start with reminding us exactly what a parallelogram is, then talking through how to find the area of a parallelogram, and why the formula for the area of a parallelogram is as simple as it is, before looking at a few common mistakes students make when using this formula. A parallelogram has two defining features. Firstly, it's a quadrilateral, which means it's a four-sided shape, and secondly, those four sides make up two pairs of parallel sides. Remember, parallel means that there is always the same distance between the two lines. One way people remember this is, if you continued those parallel lines forever, they would never intersect. They would always have the same distance between them. One of the ways we indicate parallel lines in maths is with these arrows. That is one set of parallel lines, and that is the second. For the second set of parallel lines, I use two arrows to show that these two sides are parallel to each other, but not parallel to the other sides. This shape also has four sides and two sets of parallel lines. It is also a parallelogram. This shape has only three sides, therefore it cannot be a parallelogram. Instead, it's a triangle. This shape has four sides and two sets of parallel lines. Therefore, it is also a parallelogram. This shape has four sides, but only one set of parallel lines. While the top and bottom lines are parallel, the left and right sides are not parallel. Therefore, it is not a parallelogram. Instead, it's a trapezium. This shape has four sides and two sets of parallel lines. Therefore, it is a parallelogram. And in fact, it's a special type of parallelogram called a rhombus. And a rhombus has the additional feature of all the side lengths being the same size, in the same way a square does. Now, this final shape may look familiar to you. It is a quadrilateral, and it also has two sets of parallel lines. Therefore, it's another special case of a parallelogram, but we'd often call it by its more specific name, which is a rectangle. Yep, that's right, a rectangle is a special type of parallelogram. And this gives us a little hint as to why the formula for the area of a rectangle and the area of a parallelogram might be the same, because a rectangle is just a special type of parallelogram. So it makes sense that it would have the same formula. Now we know how to identify parallelograms, let's now have a look at a visual, intuitive explanation of why the two formulas are the same. Here we have a shape. It has four sides and two sets of parallel sides, which I'm marking with those arrows. Therefore, we all know it's a parallelogram. To save us some time, let's represent the height with the letter A. Notice that that height is perpendicular at a right angle to the bottom and also the top side. Let's also take the width, which is the same at the top and the bottom, and represent that with the letter B. Now for the crucial step. Let's assume we don't know how to find the area of a parallelogram. A really useful strategy in maths is, when presented with something you don't know, try and break it into something you do know. A parallelogram can be split into three shapes. It can be split into one triangle, one rectangle, and another triangle. I've shaded those two triangles in pink to help us see the difference. Now, you might be able to see where this is going. If I just shift, or using a more mathematical word, translate one of these triangles, I can change this shape into a rectangle. As I did that, the only thing that changed was the position of one triangle. The size of everything remained the same. Therefore, the area of this blue and pink rectangle is the same as the area of the parallelogram. Now we have something that we know how to work with. The area of a rectangle is its width times its height, which I've represented with A and B respectively. So the area of a rectangle is A times B. Therefore, returning back to our parallelogram, the area of this parallelogram must also be A times B, because shifting the position doesn't add or subtract from the area. Therefore, the area must be the same. Now let's put some specific numbers into this. Instead of A and B, let's say it has a perpendicular height of 3 and a width of 8. Therefore, to find the area of this specific parallelogram, I multiply 3 by 8. So the area of this parallelogram is 24 units squared. It wasn't specified in the question that it was centimeters, so I'm just going to say it's units squared. So now hopefully it's a bit clearer why the two formulas are the same. Let's now have a look at two more examples of this in practice. Here is another parallelogram. I know it's a parallelogram because it has 4 sides and 2 sets of parallel lines. It has a width of 4 and a perpendicular height of 3. Therefore, to find the area, I multiply the height by the width, and so the area of this parallelogram is 12 units squared. Here is a second parallelogram. For this parallelogram, I'm given the dimensions of 2 and 5. Now previously, we just multiplied the 2 dimensions given to us together, and if we did that, we would get 2 times 5 is equal to 10. However, that would be wrong. Why is that wrong? Well, it's wrong because 5, in this case, doesn't represent the perpendicular height, which is what we need to use. Instead, it represents the slanted height. And if 5 is wrong, then our calculation for the area is also wrong. The correct height, which I've now shown, is 4. I've shown the perpendicular height of 4 off the shape because otherwise it'd be too cluttered, but it's always the distance between the 2 parallel lines. So now if I recalculate the area using my correct dimensions, the area will be equal to 2 times 4, therefore the area is 8 units squared. This is a really common place where students slip up, so I thought it was important to point that out. You need to multiply the width by the distance between the 2 parallel lines, which we often call the perpendicular height. That's it for this week's video. As always, leaving a like really helps me out by allowing my videos to reach more people. And if you want to find your way back for more maths videos like this, don't forget to subscribe and turn the notifications on. Thanks, guys.